Okay, so we looked at the graph of the absolute value function, and I'm going to go back and put that back into my y equals again, and so I want you to do that too. Make sure you just have in your y equals, make sure it just says the absolute value of x. That's the only thing we want on our graph in our standard viewing window right at the moment. Okay. And so here's the graph. You guys understand that. We just talked about it. What we're going to do today is we're going to take this graph and we're going to move it around left and right, up and down, and we're going to stretch it horizontally and vertically. Okay? And we're going to compress it horizontally and vertically. All right? So we're going to do transformations. And so the transformations we did back in lesson 1.8 when we were transforming points, we're going to do that now with the absolute value function. And the reason we're going to talk about this and spend some time on this is because it affects things the same way as it did when we worked with quadratic functions back in the Algebra 1 book. And we're going to spend some more time on that later on also. So when we graph just f of x equals absolute value of x or y equals absolute value of x, that's called the parent function because it's in its simplest form. The coefficient of x is 1, and there's no adding or subtracting or anything else on there. Right? So we're going to do some translations of the absolute value of x. So first of all, I want you to, on your graph paper, okay, we're going to graph absolute value of x as dotted lines. So use dotted lines when you just do the absolute value of x, and we're going to use solid lines for doing the transformation or transformed one. Now you can do some of these on the same one. I'm not a big fan of that right at this moment just because I want you to be able to see the differences. So right now take and make 2 copies of this on your graph paper. All right? Just the absolute value of x. So make sure you're going over 1 and up 1, over 1 and up 1 each time, because your slope for absolute value of x, the positive side is plus 1, the negative side is minus 1. So when we're talking about transformations, okay, there's 2 different types of translations for the transformations. One of them is vertical, and the other one is horizontal. Right? So when we have a vertical translation, which is the case here for when we're going to go down 5 units. So when we have a vertical translation, we have what looks like this. That we're going to take the function f of x, and we're going to add or subtract some number to this. So in this case, since it says we're going to go 5 units down, that means the value of k is going to be negative 5. So if I rewrote this function, I would say this is the absolute value of x minus 5. Because we're going to go 5 units down, and so the value of k is negative 5. So when I put it into the general formula, k equals negative 5. And this is important that you're able to do that. So when it says vertical, some type of vertical translation, that just means moving it up or down, we're talking about the value of k, and we just replace k with whatever that number is. All right? So we're going to graph it. If I move this thing down 5 units, does it change anything but where it's at? No. All right? So we go and move it down 5. So that means that all of these points are going to be exactly the same, moving it down. So what's the y-intercept going to be now? -5, all right? So from -5, I'll go up 1 and over 1, and both directions, positive and negative. And I don't know where that red line came from there, so there we go. Okay. And so make that a solid line when you draw that. So when you're drawing the translation, make sure you're drawing a solid line. So make sure you're saying that this is a vertical translation, 5 units down, write the new function. Okay, g of x equals absolute value of x minus 5. All right, so the orange dotted line is f of x equals the absolute value of x, and the blue one is g of x equals the absolute value of x minus 5, because we're replacing k with -5. All right, letter B. In this case, we have a horizontal translation. Now notice the general rule for a horizontal translation, g of x equals f of x minus h, where the x minus h is in the parentheses, okay? That means it's inside the function. It affects the value of x. So if I'm going to write the expression for this, if it says 1 unit left, that means that h would be equal to what number? So if it's moving left, that means it would be -1, right? Okay, so we're going to replace h with -1. So g of x equals the absolute value of x minus a -1, or absolute value of x plus 1. Things that happen vertically, things that happen horizontally are opposites, okay? Vertically, if it says plus, we go up. If it says minus, we go down. Horizontally, if it says plus, we're actually going to go to the left. And if it says minus, we're actually going to go to the right, because the value of h is negative when I end up with a plus here. It's positive when I have a minus. All right, so we draw the line. So what happens if I shift it 1 to the left? Okay, so what changes then? Okay, the x-intercept is going to change. Instead of it being at 0, it's going to be at -1. So when I draw the transformed function from the original, they should be, in this case, when all we're doing was horizontal translations or vertical translations, they're going to be parallel. Okay? Going to be parallel. So when I have a vertical translation, the y-intercept changes. Okay, that's our focus on the change. When we have a horizontal translation, we think about the x-intercept changing, okay, moving, all right?
I put that in there. What about
The reason we're working on showing the actual functions too is so that you can check them with your calculator to make sure you're doing them correctly, all right? All right. Okay. All right, here I want you to just write the expression, okay? Don't graph it, all right? I want you to write what the new expression would be. So when we're looking at transformations, all right, if it's vertical, it's outside of the function. This is the way I try to think of it for myself. It's outside of it, okay? It affects y, not x. If it's horizontal, it's inside the function, all right? So x minus 2. And always, when you look at it for horizontally, it's always going to be the opposite sign of which direction you're going when you're done. Okay? So it says minus 2 here, I'm going to the right. It says plus 2, I'm going to the left. Okay? All right? The vertex of an absolute value function. So here's that vertex form. We did it with quadratics. If you remember when we were working with it with the quadratics, it looked like this, that we would say that g of x was x minus h, x minus h squared plus k. Do you remember that now? Remember seeing that? Maybe, maybe not. All right? But for absolute value, all right, so we have, this is what we call the vertex form for an absolute value function. G of x equals absolute value of x minus h plus k. Okay. Where h is our horizontal translation and k is the vertical. So it says we want to translate the absolute value of x so that the vertex is at the point -1, -3. Currently, it's at the origin 0, 0. So what does that mean we're going to do to the graph? If I'm going to move the vertex to -1, -3, what am I doing to the graph? Okay, we're going to move it to the left 1 and down 3, right? Okay. So in this case, h is equal to -1 and k is equal to 3. So whenever you see a vertex, they say, hey, here's the vertex. That means that that's h and k. Okay. The x value of the vertex is h, the y value is k. So my new function is going to be that g of x equals the absolute value of x plus 1, because we're going to the left, and then we're going, that should be minus 3, and then we're going down 3, so minus 3. Okay. Sorry, this k should be -3. Okay. So graph absolute value of x, first of all, is a dotted line, and graph your transformed function there, from there. All right, so put that on your paper too. All right, so we'll take our vertex, plot that point over here then at -1, -3, and then from that spot we will draw our new graph. All right, so I want you to do this one then. Okay, so in this case, h is 4, k is -2, so I just put 4 in for h, -2 in for k. Find my vertex, which is at the point 4, -2, and then draw my graph from there. Okay. All right, now we're going to get into a little bit harder transformations. So we're going to look at reflections and stretches and compressions. Now we didn't do this with lines, and so we're just going to use the absolute values to go over this together. Right? But you're going to want to make sure you have these rules written down. All right? for a vertical translation. I mean, really all you need for the vertical and horizontal ones, you could just have the vertex form. You could have that form down and just let yourself know, okay, H represents a horizontal translation. K represents a vertical translation. Now, if we're going to do reflections, okay, a reflection across the x-axis says that g of x equals negative f of x, which what that means then is all of the y values are going to change signs. All right? So this means y values change signs. If I can spell that word right. Okay? No singing, but signing. Here, this one means the x values change signs. So a reflection across the x-axis, that's a vertical reflection, changing the signs of y. Reflection across the y-axis, we call that a horizontal reflection. So we change the values of x. So in our one that we're working with, this would be negative absolute value of x, and this would be absolute value of negative x. All right. Vertical stretches and compressions. All right, and I'm going to actually put this on another page, so bear with me just for a second. Oops. All right, so on this one then, right, the vertical stretches and compression. So if, let's see if I can cover that up. So when A is greater than 1, it's a stretch. And this means that we're going to have a steeper slope. If A is between 0 and 1, all right, then it's going to be a compression, which means then our slope will not be as steep, okay? It's going to be a lower, smaller slope. Now notice with the g of x or when it's a horizontal stretch or compression, notice that it's in the parentheses like we would expect, but it's 1 over b, it's not the value of b. All right? So what happens horizontally then is it works the opposite. Just like instead of when it says we're going to go to the right, it ends up being a negative. Right? So horizontally, if b is greater than 1, we actually have a compression. And guess what, though? The lines are going to get, or the slope is going to be steeper. So this is going to give me a steeper slope. Okay? And when B is between 0 and 1, it's a stretch horizontal stretch, and the slope is not going to be as steep then. It's going to be a lower steepness, less steepness. Okay. All right. Okay, so let's take a look at that then. Okay, we're going to perform some transformations. So first of all, it says reflect the graph of f of x equals absolute value of x minus 2 plus 3 across the y-axis. All right, so first of all, I'm going to have to move my graph here. So here's what I want you to do first. Okay, I want you to graph this. Okay, absolute value of x minus 2 plus 3. All right, so go ahead and take a moment to graph it. So this is what happens if we're going to reflect across the y-axis. All right, so that means we're going across this axis here, right? Okay, all right. So if I'm going across the y-axis, what's changing? Is it the x values or the y values that are going to change signs? Let's go back up here and look. All right. Reflection across the y-axis means that the x values are going to change signs. Isn't that special? So all of your x values here then, so my vertex is now going to be where? Okay, instead of at 2, 3, it's going to be at negative 2, 3. Right. This point here that's at 1, 4 is going to be at negative 1, 4. The point here at 3, 4 will be at negative 3, 4. Right. And once I have my vertex and a point on each side of the vertex, then I can go ahead and draw my graph. Oops. What's the new rule then? What's my new rule? Well, where's the vertex at now? Negative 2, 3, so h is negative 2, so this will be the absolute value of x plus 2. And then my y value stayed the same at 3. All right, so look at another one. Okay. Letter B, they want us to stretch the graph of f of x equals absolute value of x minus 1 vertically by a factor of 2. All right, so I'm going to move my graph here. Okay, so go ahead and... Okay, so if I'm stretching it vertically by a factor of 2, all right, since A is that factor, okay, so since I'm going to be doing it by a factor of 2, that means the value of A is going to be positive 2. So that means it's going to be a vertical stretch, and it means that when I'm done, I'm going to have a steeper sloping graph. Okay? So we are going to replace, or we're not going to replace. So when it's a vertical stretch, that means that g of x is equal to a times f of x. Okay? Which in this case means that we're going to do 2 times the whole function. So if I want the new rule for this, the new rule is going to be 2 times the absolute value of x minus 2. It does not go inside the absolute value. You can't take something that's outside the absolute value and put it in. Okay, so it has to stay out front, but I also have to distribute it to the 1. So my new rule is going to look like this. All right, and we're going to verify this with our calculator that it looks right. But first of all, let's do it. Let's use our brains to do this. So we're stretching. What's changing, x or y? Okay, it says vertical, so just y is changing, okay? So let's pick a point. Here's our main point, right? The vertex, all right, at -1. What happens when I multiply that y value by 2? What's -1 times 2? -2. So my new point is going to be down here at, let's use blue, -2. So my y-intercept is at -2 instead of at -1. All right. Let's pick a couple other points. All right. So let's look here at 0. All right. Those two y values are 0. What happens when you multiply 0 times 2? You still get 0. So on my new graph, these are still going to be at 0. Okay. Let's pick another one. All right, nice easy ones. At 2. All right. At 2, the y value is 1. What happens when I multiply that y value by 1? What do I get? 2. All right, so this is now going to be here. All right. And at -2, the same thing happens. So all I'm doing is multiplying the y values by 2, and now I can draw my new graph. And you'll notice that this graph is definitely steeper than the previous one. Our previous one had a slope of 1. This graph now has a slope of 2 or -2, depending on which side of the vertex you're on. All right, so if it's a vertical stretch or vertical compression, we're just changing the y values. Okay. All right, let's look at one more. And we're going to do, oops, that one there. Yep. Letter C, sorry. There we go. So we're going to take the graph of absolute value of 4x minus 3, and we're going to stretch it horizontally by a factor of 2. All right, so here's where we're going to use our calculator to help us out here. All right, so once you write it down, graph it on your calculator first. Okay, so we're going to graph this one on our calculator. Absolute value of 4x minus 3. All right, so here's the graph. All right, so the vertex is at -3, right? 0, or 0, negative 3. Okay. And this was pretty steep, isn't it? So let's see, I need another point. Where can I find some other points? The table. All right, so let's go to the table. Oh, I need to change my table. Negative 5. All right, so here's my table. All right, so I'm going to use the points from my table to make my original graph. So I have 0, negative 3, negative 1, 1, and 1, 1. All I need is 3 points to do this. Okay. So let's see, I got to get rid of this. This is delete and delete. Okay. So we have a point at 0, negative 3, and at 1, 1, and negative 1, 1. Oh. What is the slope of those two? Anybody know? What? 4 over 1 and negative 4 over 1. Hey, look at this. There's the slope, positive and negative. All right. Get back there. Okay, so we're going to stretch the graph horizontally by a factor of 2. That means all the x values are going to do what? What are they going to do? They're going to double. Okay? So, where am I going to go to do that? I got 2 places. I could go back and look at my calculator. Alright? Or, how many points do I need to draw this graph? I only need 3. I need the vertex, and hey, I got those other 2 I just put on here. Alright? So what's the x value at the vertex? 0, right? What happens when I multiply 0 times 2? What do I get? 0. Okay. So my new point is still going to be at 0. Okay? What's my x value here? Positive 1. What happens when I multiply positive 1 times 2? What do I get? 2. So this is, I'm just going to slide that point over to 2. And this one here that's at negative 1 is going to be over here to negative 2. Just taking those x values and multiplying them by 2. So then I can draw my new line. So if we looked at other points, up here I have a point. Here's a point at 2, 4. Now the new one should be over here, but it's going to be close now. We're going to be perfect at 4, 4. Okay, we double 2, we get 4. Here at negative 2, 4 ends up at negative 4, 4. Well, I guess it was at 5. Okay. Now, what about the rule then? Okay. Here's the big tricky part, is the rule. G of x equals f of 1 over b times x. In this case, because it's a horizontal thing, that means that b is equal to 2. So this becomes the absolute value of 1/2 times 4x minus 3. Because what we're doing is we're multiplying x Whatever started inside here, we're multiplying it by 1 over b. And since it already had 4x in there, we're going to multiply that 4x times 1/2. So my new rule would be absolute value of 2x minus 3. So the slope is now going to be 2 or negative 2 instead of 4 or negative 4. So a horizontal stretch actually makes it less steep. I'm mostly concerned about the graphs, okay, that you can make the graphs correctly. All right. Bonus if you can do this, okay, because the horizontal ones are the hardest, okay, as far as when it comes to stretching and compression, writing those new functions. All right. So if you have a hard time with that, you won't be alone, okay, but you should be able to do the graphs. All right.